Okay, good evening now. We should start with the session. Yesterday we had completed the software block 2 part, right?
Yes, ma'am.
Any doubts in that part?
No, ma'am.
So today we are starting
What?
block 3 that Hanji boliye. Were you saying something?
No, ma'am. No, ma'am. Sorry.
Okay, so we'll start with block 3 now, where for block 3 first unit, that is your computer networks, right? Regarding networks. All of you should put your attendance in the chat box, remember that, with your name and enrollment number. So first of all, what we will learn is basic concepts of networks and uses of networks in sharing of resources, backups, and common types of networks, which we have LAN, WAN, and MAN basically. And there are other types of networks also. So we'll also learn about network media, the wireless or wire-based medium. So you have wireless networks, threats to the networks you can learn, and the internet world and cloud computing. We have already seen that cloud. What is cloud computing? We'll see that again. So what is a network? Anybody knows about what is a network?
Interconnection of computers.
Yes, it's an interconnection of computers. So why do you want to interconnect the computer?
Sharing
For
files.
sharing resources.
To share resources and to communicate, right?
Network is a transmission of data.
What?
Network is a transmission of data, both
Yeah, it will
wire and
transmit
wireless.
data. That means you are communicating with the other computer, na? Right. A computer network is a group of computers or devices. Computers or devices are also known as nodes in a network, right? That use a set of common communication protocols. So what are protocols? First, you should know what are protocols. Do anybody knows what are protocols?
Rules.
Protocols are a set of rules.
Yes, they are set of standards or rules which the network or the communication through which the communication will happen. There are certain protocols which have been developed through which you will transfer your data from one computer to another to communicate, right? So with the common set of communication protocol over digital interconnections for the purpose of sharing resources located or provided by the network nodes. So basically what you are doing in a computer network is you are making a group of computer nodes or networks, group of computers, so that they can communicate, and communication is through protocols over the digital interconnection. Digital interconnection means through wires. You are either wireless or wire based communication you are connected to share resources and to provide data from one computer to the other. That is what networks are, right? And the nodes of a computer network may include personal computers. Nodes can be anything: personal computers, servers, networking hardware, or other specialized or general purpose hosts, right? So nodes can be anything, right? And the interconnections between nodes are formed from a broad spectrum of telecommunication network technologies based on physical, wired, optical, and wireless technology. So basically, how do you interconnect the systems are, or the nodes are? You will interconnect the nodes either you can interconnect through wires, that is physically, or you can interconnect wirelessly, or you can interconnect optically. Optical wire is also there, right? So these are the things which you should know about the network. So network is an interconnection of computers, right, for sharing and communicating with other computers. What is a communication protocol? That is a set of rules for exchanging information of a network. So you have set a standard or rules through which you will communicate or exchange information over the network. That is a protocol, right? So if we talk about a network diagram, see all these devices are connected with each other, right? So here you have wire-based connection. You have this system is connected to a scanner and a printer, and this is a switch. Switch is a networking device to connect different PCs and devices together. So here your server is connected, another PC is connected, this PC is connected, then scanner is connected, printer is connected to the switch. And this switch is connected to the fiber optic cable to the modem. Why it is connected to the modem or the router, you can say it is a router. So why is it connected to the router with the fiber optic network cable? So that it can connect to the internet. Right. So router, nowadays what you have, broadband routers are there. So the ISP, internet service providers, when you want to have internet at your home, you tell them to install broadband connection. So they give you a router, and that router is will have a fiber optic network cable connection, right, which you can put into your PC LAN card, or you can have a wireless based broadband connection, so that then you won't require any wire to be connected to your PC or your your laptop or your mobiles. You can connect wirelessly. So that kind of a thing is generally a, what is this? What is this? This is whole is a network. So you are connected to the internet and you can communicate with the internet, share the resources. That means people can give print on this printer also. If number of PCs are connected on this switch, people can give print on this printer. The scanner, they can scan the things, and on the server they can save the things and request for certain things from the server. Do you understand? Right. So this is a kind of a network, a broad view. Right. So what are the advantages of uses of a network? So there are moments in any business when several workers may need to use the same data at the same time, right? We require certain times that in business that some data has to be needed by all the employees in our, or several workers or several employees in our organization. Yes. Then what we need to do? We can connect them to the server through a communication medium, or we can interconnect them and they can share that data and use that data, right, at the same time on a network. So for that reason you can use, right, simultaneous access you can use. Then shared peripheral devices, that means you want to share certain devices on the network, then also you can use the network, right? Like you have in your organization you have one printer, or so some of the employees have to give print. So what they will do is they will share the printer in a network, and whoever wants to give the print, he can give the print on that shared printer, right? So shared peripheral devices, for that you can use. Or personal communication. Personal communication means you can do voice over internet protocol, that is VoIP, which transmits your sound over a computer network using the internet protocol. Or you can do video conferencing nowadays. So like we are also communicating through Google Meet, right? So for all these things, what you will use?
Network.
You will use the network. You can use it for simultaneous access, you can use it for sharing the devices, you can use it for personal communication, right?
Yes, ma'am.
And also you can use it for easier data backup also. How will you use it for easier data backup? Like for example, we are talking about the cloud, right? So you can keep the backup on the cloud also. So that kind of a thing, right? So what are the different networking devices you use? One is a NIC card. Do you know what is the full form of NIC? NIC is Network Interface Card, which is your LAN card, right? What is the full form? It is NIC, Network Interface Card, which is your LAN card, which is if you don't have a LAN card in your system, what will happen? You will not be able to connect to the internet, right? Or to another PC. So you should have a LAN card to connect to a network, or to internet, or to another PC. You need an NIC card. And in this NIC card or in this this LAN card, your wire, Cat5 cable wire is attached basically. Right, so we'll talk about that later. The second one is a repeater which amplifies your signal. Sometimes what happens is sometimes you have a long distance communication. So if you don't, if so after some time the signal strength of your wire gets deteriorated, right? So what happens is you want to amplify the signal, or you want to for that reason your repeaters are used. So we'll talk about the definitions of each of them. So one is a repeater, the other is a hub. Hub is like a central switch, right? Central switch where you can connect number of PCs in this hub, right? It will have interconnection of computers. So that is a hub. Then you also have a switch. So hub and switch are different, right? It switch nowadays is generally used in your labs or in your organizations where a number of PCs have to be connected from one floor to the other. So they require switch and they can connect a number of computers in a network, right? Then you also have bridge, right? You also have router. I have told you router basically routes your, it finds the best path to communicate with the other device. So it gives you the fastest or the best path through which the communication can happen. That is a router. And you also have a gateway. So we'll talk about these networking devices. So you have NIC card, repeater, hub, switch, bridge, router, gateway. Do you understand?
Yes.
Right. And a firewall also. What is a firewall? It's a firewall can be a software firewall, can be a hardware also. Hardware firewalls are also there. Do you know that? So we are talking about networking devices. So this must be a hardware firewall. Hardware means we can touch, right? So hardware firewall, what will it help in? Any outside unauthorized access is happening from outside. It doesn't allow unauthorized access from outside. If somebody is breaching your network, it takes care of that. Do you understand? That is a firewall.
Yes.
Right. So this is your NIC card or your LAN card. See here, this is put inside your PC. The motherboard is on the motherboard. It is attached, and here what you insert is your Cat5 cable with the RJ45 connector, right here. If you have seen somewhere that a cable is connected to the
And the Ethernet cable.
Yeah.
Ethernet cable. Ethernet.
Yeah, Ethernet cable. So that is your LAN cable or Cat5 cable with the RJ45 connector. So this is the point where it is connected. So this is your NIC, Network Interface Card. So NIC is used to physically connect host devices to the network media. NIC is a printed circuit board that fits into the expansion slot of a bus on a computer motherboard. It can also be a peripheral device. That means it is a hardware device. NICs are sometimes called network adapters. What are NICs? Are other name of NIC, network interface card, is network adapters also. Each NIC is identified by a unique code called a MAC access control, right? That is MAC address. So each NIC have a unique address. Do you understand? हर NIC का एक unique address होता है, and that address is known as media access control MAC address. It is known as physical address, right? This address is used to control data communication for the host on the network. So this is the address which controls the data communication for the host on the network, right? So this is your NIC, LAN card. Do you understand?
Yep.
Right. Then when we talk about this is your repeater. This kind of a system is a repeater. This is also a kind of a LAN cable connector which is there, right? So a repeater is a network device used to regenerate a signal. So if your signal strength goes low or deteriorates, then or some problem is there in the signal. So to make it to make it again strength should be there in the signal. So you regenerate a signal. For that thing you require a what?
Repeater.
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 So repeaters can regenerate analog or digital signals that are distorted by transmission loss due to attenuation. So because of some attenuation means because of noise or because of some problems, some transmission loss is there. So to regenerate that signal and make it more strength. So you have repeaters, and repeater does not make an intelligent decision concerning forwarding packets. So basically, repeaters are not like routers, right? They cannot make a decision that where this packet will be going. Forwarding of packets is not the decision of repeater. Do you understand? So it's not an intelligent decision maker, right? So that is your, what is this? A
Repeater.
repeater, which regenerates your signal. And then is your hub, right? So hubs concentrate on connections. So basically, if you want number of computers to be connected to a hub, so what does hub will have? They will have a group of computers in a single unit connected. So it is a single unit. So in other words, they take a group of hosts and allow the network to see them as a single unit. So basically, you will think that it is a single unit, but actually there are number of computers attached to that or number of hosts attached to that hub. This is done passively without any other effect on the data transmission, right? Active hubs concentrate hosts and also regenerate signals. So some of them, some active hubs, what they do, they also connect the host also, and they also regenerate signal also, like repeaters, right? So both the things they are doing. So that is a hub, right? So you have number of connections here, right? Here you will have number of connections. In this, your LAN cable will be connected here, right? So you will think that it is a single unit, but there are number of PCs connected in this. So that is a hub. Then you have bridge. So bridges convert network data formats and perform basic data transmission management. So basically from one network to the other network, if you want to connect, this is one network. Can you see that?
Yes.
This is one network and this is another network. So both the networks, if you want to connect, so you will use a
Bridge.
bridge, right? So bridge provide connection between LANs, right? So not different networks, same network. Do you understand? If you have same kind of network like LAN, local area network, then it can connect both the LANs together or 3 or 4 LANs together. So that is a bridge, right? They also check data to determine if it should cross the bridge. This makes each part of the network more efficient. So it also checks whether the data can pass this network or not, or cross this bridge or not, so that the other network can take it or not. That is, so this makes each part of the network more efficient also, right? So if certain data cannot pass that particular network, so there will be restrictions, and bridge also checks that this data cannot pass this to the other network. It will remain in that network only. So that is a bridge to connect two or more LANs, right? You will have bridge, two or more networks, right? Then you have switch. Now switches add more intelligence to data transfer management, right? They can determine if data should remain on a LAN and transfer data only to the connection that needs it. So basically, like a hub also had number of connections where you can connect your PCs. But what does hub and switch have a difference is, first and foremost, switches are intelligent and for data transfer, and they will determine which connection is requiring for data transfer. Only for that they will allow. They will, so what in hubs, what happens is, if you want to transfer to a particular computer some data to all the host or all the nodes, the data will go, and to the intended node will take that data. Do you understand? In a hub. But here what will happen if this computer wants to send data to this computer, it will only go from here to here, right? Not to all the other computers. Do you understand? So they can determine if data should remain on a LAN and transfer data only to the connection that needed. So that is what is another difference between a bridge and switch is that a switch does not convert data transmission formats. So basically some bridges, what they can do is, if we have seen the earlier one, what does bridges do? They can perform, they convert network data formats and perform basic data transmission management. So they also transform your data, or that means they convert your data formats also, bridges. But switches cannot convert your data formats. Can you understand? Suppose some other computer will understand, or some other network will understand some other format, so they can convert also bridges. But switch cannot convert. This is another difference, right?
Ma'am,
So
can you
this is
please
a
switches?
what? Can you repeat?
Switches. Actually, my
Switch.
network was poor.
Switch. Switches are actually just when you have seen a hub has number of connections, right? Like a switch,
Yes, ma'am.
right? But hubs are not intelligent, right? That means
Yes.
they, if they want to transfer some data to a particular PC, they will the data will go from one PC to all the PCs connected will receive it will broadcast the data, and the person who is the data is intended for, he will take the data. But in switches, what happens is only to the intended computer the data will go from the switches. Suppose this computer.
Your audio is stuck.
Ma'am, your voice is not coming.
I guess it's a network issue.
In a small network, no, in a local area network, or you can say you can put switches there. We are not using hubs right now. Generally, we are using switch only. In a building or something, you want to connect your computers, and you can use these switches to connect number of computers in that, right? Then, what is a router now? What is a router? Router have all the capabilities listed above. Whatever capabilities were for other devices, router can do that. Router can regenerate signal, concentrate multiple connections, convert data transmission formats, and manage data transfer. Can you see that? Whatever the other devices could do, which we have seen earlier, right? The bridge, the switch, the hub, right? The repeater. The router can do all the things. Can you see that? It can regenerate signal like repeater, right? It can
Yes.
concentrate multiple
Yes,
connections like
ma'am.
hub and switch. It can convert data transmission formats like bridge
Bridge.
and manage data transfer, which all of
Switches.
them are doing, right? So they can also connect to a WAN, which allows them to connect LANs that are separated by great distance. So basically, bridges were only aligned to connect two LANs, right? Or two or three LANs, similar network. But router can connect dissimilar networks also. WAN and LAN can be connected, wide area network and local area network can be connected. Can you understand?
Yes.
Right?
Ma'am, what is WAN?
Wide area network, that is your kind of an internet where all the all the countries and all the world computers are connected. That is your internet, WAN, wide area network. In a building,
Okay.
if you in a limited area, 100 meter or something, in a limited area, if you say 1 kilometer area, if you connect a computer, that will be local area network, right? In a building you have connected, in a college you have connected. Do you understand?
Yes,
That is
ma'am.
local area. When you connect metropolitan cities, that is MAN, metropolitan area network.
Okay, ma'am. Thank
Right.
you.
And if you connect the all over the world, your internet is a wide area network. We'll talk about that later. Will come. Then the other device which was there was gateway.
Gateway.
Right. One thing router also does is it routes the path of the packets to the destination computer, the best path it finds out. Do you understand? You should know that suppose you are transferring some attachment, some email you have given to some person, and that email goes with the attachment you are sending. So some suppose 5 MB or 5 MB or 6 MB your data is there, suppose with the email, right? Do you understand? So your wire or your medium, your telephone wire or whatever medium you are using, so that wire cannot take the whole data and transfer it to the other destination. Do you know that? How much can the telephone wire can take? That is known as your bandwidth, right? So bandwidth matters 100 Mbps, megabits per second, or depends on your speed and all, how much megabits per second the data can be transferred, right?
Yes.
Right. So what happens is, first you have to make that data into packets. 100 Mbps, megabits per second it can transfer, the 100 megabits packets it has to make. Right, with each packet having the destination address and the frame number, that this is packet number 1, this is packet number 2, and the destination address and the source address. Do you understand? And what happens is from when it is converted to packets, and then the router, what it does is it takes the packets and routes to the best path which is there to reach the destination, and it will what happens is at the destination they will not reach as 1, 2, 3, 4 packets only. They can reach 10. The 10th packet will reach first, and the second packet will reach last. It may happen. And after that, when all the packets have reached the destination, they will rearrange it, and your data will again be back to the same form, and the email will reach the destination. Do you understand? So router has another work also. It routes the packets best. It finds the best path and routes the packet to the destination. Right. Then we come to gateway. What does gateway do? Gateway is a piece of networking hardware used in telecommunication for telecommunication networks that allow data to flow from one discrete network to another. So gateway is another thing which is actually right now we are using. Actually, we are doing this only. Dissimilar networks have to be connected. Somewhere it is some kind of network. Somewhere it is some kind of network. To connect all these networks, we are using what? Gateway. Right, telecommunication network basically. And gateways are distinct from routers or switches in that they communicate using more than one protocol to connect a bunch of networks. So why, how routers and switches are different from gateways? Gateways have more protocols in it. That means suppose if it is for email, it will have a protocol. It is for hypertext transfer protocol, or for transferring it will have different protocols. So for different networks it will have many protocols in it, so that it can connect to the different types of network. Right. So that in that way routers and it is different from routers and switches. But it is also a networking device to connect different types of computers or different networks. Right. So this is also a networking device. That is your gateway. Right. Then you have firewall. So a firewall is a network device or software for controlling network security and access rules. Right. So for security reason, what you put is a firewall. So this is a hardware firewall. See, network device or software. So a firewall can be a software firewall, like in your Windows, you have Windows firewall, right?
Yes.
So that is a software firewall. But you can also have a hardware device, which is a firewall, which controls the network security and access rules. So unauthorized access, it stops the unauthorized access from outside. Do you understand?
Yes.
Right. So firewalls are inserted in connections between the secure internal networks and potentially insecure external networks such as the internet. So this is your internet, right? And in between you have put a firewall, and this is your router, which will go from the hardware to the internet. And if whatever communication will be coming to the to your network will go through this firewall, and then it will come to you. Right. So it is put in between. Firewalls are typically configured to reject access requests from unauthorized sources while allowing actions from recognized ones. So it will only allow the recognized sources which the network or which the company has allowed, that these people can connect to the network, but these people or these things are not allowed to connect to the network. So they will not be allowed. So that kind of a thing is firewall, and the vital role firewall play in network security grows in parallel with the constant increase in cyber attacks. So basically firewall, what they help in, because nowadays too much of cyber attacks are there, so it helps you in parallelly taking the security levels high, so that you don't get any unauthorized access from any such kind of cyber attacks. So that is what firewall is, right? Right, so these were your gateway, firewall, router, switch, bridge, hub and repeater. These are your what? Networking devices which you use to connect to your network, right? Then now if I want to connect one PC to the other, or a number of PCs, so what media or medium I will use to connect? Right, I can use a wire-based medium or a wireless medium, yes? Some medium has to be required now to connect.
Yes, ma'am.
Yes.
That is network media. So the function of the media is to carry a flow of information through a LAN. So basically your media will carry your information. The wire will carry your information from one computer to the other. So you have wired media, which is guided media. In your book it will be written what? In your book it will be written guided media and unguided media. Two kinds of network media. Do you understand?
Yes, ma'am.
Guided means where wire is there. Guide is a wire based medium is guided medium, and where wireless medium is there, that is known as unguided medium. You understand?
Yes.
Why guided? Why the word guided have been given? Because you know that wire is going from where to where, na? So guide is there. Yes or no?
Yes.
Yes, ma'am.
Right. And where you don't know where the, because wire is not there, you don't know how the connection is being made, that is wireless, unguided. Right.
Yes.
So wired media, widely adopted family that uses copper and fiber media in local area networks. So basically, they are collectively known as Ethernet. Right. So in wired media, there are copper cable and fiber optic cable, two kinds of cable. Right? Do you understand?
Yes.
When you connect from one PC to the other, so either you have copper cable or you have fiber optic cable, and both of them collectively are known as Ethernet.
Ethernet.
Right? In the local area network. So how many types of copper cable are there? You have coaxial cable, you have shielded twisted pair and unshielded twisted pair. Or you can say you have coaxial cable and twisted pair. Twisted pair is divided into shielded twisted pair and unshielded twisted pair. Right. So, and the second is fiber optic. Nowadays, generally, most of them are fiber optic cable, right?
Yes.
Most of them are fiber optic cable, which generally is coming to your home for the internet, right?
Yes.
And wireless media, when you talk about, they use the atmosphere or space as the medium.
Yes, like a tower or a receiver.
Yeah. So your atmosphere or space or this will be used as a wireless medium. So that is wireless media. So you have two kinds of media: wire media or guided, wireless or unguided, right? So first we talk about the wired media, that is your copper cable, right? The most common, easiest, quickest and cheapest form of network media is to install is your copper cable, right?
Yes.
And the disadvantage of sending data over copper wire is that the further the signal travels, the weaker it becomes. If you take data, the data travels from the copper wire, what happens is after some time the signal strength goes weak. Because of that, what we have to do, repeaters have to be put, right?
Yes.
Earlier when people had cable TV network, right? People had cable TV network. Right now, though, people have got Tata Sky and all that in their home, but earlier when cable TV network was there, so this kind of a medium was generally used, right? So that is copper cable basically, right? So we talked about three kinds of copper cable we talked about. The first one is coaxial cable.
Coaxial cable.
Can you see this cable?
Yes.
This is a coaxial cable. It can be run longer distance than twisted pair cables. Right, and speed is 10 to 100 megabits per second. Cost is inexpensive, that is, it is not expensive. Media and connector size is medium, and maximum cable length is 500 meters. Right, so you have a inner copper conductor, and above that you have a what you say shield above. That is the white color one. That is the plastic insulation. Then you have the above braided copper shielding above this and outer jacket.
Jack.
So generally this was your cable wire earlier, right? Coaxial cable. So this is inexpensive and it can take longer distance. It can travel longer distance than twisted pair, right? So this was coaxial. Then was your shielded twisted pair, the second one, right? So this is a shielded twisted pair. See the wires are twisted in between here,
Yes.
Yes.
right? Here the twist is there, so that's why it is called twisted pair, right? So it's the speed is from 100 to 0 to 100 megabits per second, like the coaxial cable also. Cost is moderate. Maybe little costlier than the coaxial cable. Media and connector size medium to large. That means your connector size can be medium or can be large also. Then maximum cable length is 100 meters. See that the other one was
500.
this was
500.
500. This is 100 meters now, right? So that means that coaxial cable can travel long distance
Longer.
than this. Right. So here also you have twisted pair wires and you have a foil shield that is your insulators of plastic, and then braided sheet that is copper braided sheet, and then jacket that is the covering. Right. Then when you talk about unshielded twisted pair, unshielded means what? There is no shield above. Right. So UTP is a 4-pair wire medium used in a variety of networks. So can you see here different wire mediums? Yes, these wires. Right? Different colors wires are there. Can you see that?
Yes.
Right? And they are twisted. Right? So generally UTP, unshielded twisted pair, is a 4-pair wire. 1, 2, 3, 4 pair wire. And pair means each and every wire is a pair. This orange color is a pair. Green color is a pair. 2 wires are there twisted. Right? Used in a variety of networks. Right? And each of the 8 copper wires in the UTP cable is covered by insulating material, and above it is an insulating material that you can say a jacket or something, outer jacket, right? Then speed is 10 to 100 to 1000 megabits per second. Can you see that? It has much higher speed, right? And least expensive it is. Media and connector size is small. And maximum cable length is 100 meters, depending on the quality or category of cable. Right? So which wire are you using for your LAN? To connect one computer to the other? Which is being used? Can you tell me? This one is used.
Unshielded.
What?
Unshielded.
Unshielded, yes. UTP cable is generally used inside a LAN. So this is the cable you use.
RJ45.
And above, after this, you will connect it with what? These wires which are twisted in pair, you will make it straight. And then
Connect
there
it
is
to
a
the
color
connector.
coding mechanism. There is a, what it is? Color coding mechanism is there
There's
to put it in the RJ45 connector.
Yeah, a sequence is there.
There is a sequence, so then it will be put straight, and a sequence of red, white, whatever, green and all that will be put, and then it is put in the
RJ45 clip.
RJ45.
Or
This is
cat.
the connector.
Yes.
This connector, it will be put inside this, right? So EIA or TIA specifies an RJ45 connector for UTP cable. So this is your RJ45 connector. The letters RJ stands for registered jack. What is RJ? Registered jack. So this is what you put inside your NIC card. This RJ45 and your or your router or modem, whatever you have, that all one goes in the modem or router, and the other goes into your what? In your laptop or systems.
Adapter.
Right. So that is there. This is your RJ45 connector for the UTP. Right. So these three were copper wires. That is your coaxial, shielded twisted pair, unshielded twisted pair. And the maximum distance which can be covered is through the coaxial cable, right? And that was used in your cable networks earlier, right? Now, fiber. When we talk about the second wired-based medium is the fiber optic cable. So this is your fiber optic cable now, and it is a glass fiber carrying light pulses, each pulse a bit. Can you understand? Optical medium it is. It is optic. Optic means what? Light.
Glass. And yes.
Right. So light travels in pulses in this glass fiber, right? And based on the total internal reflection of light, it works. And high speed point to point transmission, that is 10 to 100 gigabits per second. So the speed is very high of fiber optic. Can you see that?
Yes.
Of transferring data. It's gigabits per second, not megabits per second. And low error rate. That means repeaters spaced far apart. That means signal strength is good, right? Error rate is not there. Immune to electromagnetic noise also, right? So means noise problem is also not so much of attenuation is not there in your fiber optic, and this is laid generally underground. Right, above it is a wire cover, plastic cover wire is also put above this glass fiber. Right, so that is your fiber optic. So nowadays, generally from the ISPs, generally fiber optic cables are given nowadays for the broadband. Right. Then when you come to communication, now we talk about communication. So this was your media. What media? Wire-based media. What about the wireless media? What are the different wireless media? Can anybody tell? You have radio frequency, radio waves are there, microwaves are there. Have you heard about them? Satellite connection is there, right?
Yes.
And Bluetooth technology is also there. Bluetooth is there or not?
Yes. Yes, ma'am.
Right? Infrared is also there. Have you heard about that?
Yes, ma'am.
Your remotes in your for TV and your
Yes, ma'am.
ACs are what? Infrared. Right? They cannot travel walls. Can you understand? They cannot penetrate walls, the infrared ones. Right? But radio waves can travel walls, right?
Yes, ma'am.
Right? So, and what does there are microwaves also, satellites also, and your Bluetooth connection. Bluetooth connection has a what is the distance is the matter. How much distance it can cover. That is the Bluetooth connection. Too much distance between the devices, it won't be able to connect to the other device. Right. So we'll talk about that. So internet, when we talk about communication protocols, so we talked about that protocols are rules. So how from one computer to the other in a network, you transfer data that are done through certain rules, and those are known as protocols. So internet protocol suite, that is known as the TCP or IP, Transmission Control Protocol or Internet Protocol. What is the full form of TCP? Transmission Control Protocol or Internet Protocol is the foundation of all modern networking. TCP/IP, right? It defines the addressing, identification, and routing specification for IPv4 and for IPv6. What is IPv4 and IPv6? Internet Protocol version 4 and Internet Protocol version 6. Right? So version 4 was earlier used, right? And now we have because the addressing scheme have Internet Protocol addressing scheme has been increased, so that is IPv version 6. It was IPv version 4 was 32-bit, IPv version 6 is 64-bit. You understand?
Yes.
Addressing has been increased because now number of computers are more increased more, so more addresses are required, IP address. So that's why it is now IPv version 6 from IPv version 4. So it is the defining set of protocols for the internet. So TCP/IP is the main foundation, Transmission Control Protocol or Internet Protocol. That's the main protocol suite. And IEEE 802, IEEE standards dealing with local area network and metropolitan area network. So basically IEEE is an organization which is setting the standards for these protocols also, and dealing with local area network and metropolitan area network. So they operate mostly at levels 1 and 2 of the OSI model. So when we talk about the OSI model, see how your network transfers data from one computer to another. So there is a model called Open System Interconnection, OSI, right? So your IEEE mostly operates at first and second level, physical and data link layer. So we'll talk about that, right? And Ethernet, it is a family of protocol used in wired LANs described by a set of standards together called IEEE 802.3. So Ethernet is also kind of a protocol which is used generally for wired LAN, local area network standard, for transferring data from one PC to another. That is Ethernet. So that is also there. So when you talk about the OSI, Open System Interconnection Model, right? OSI has different layers for transferring data from one computer to the other. This OSI model is followed, right? So there are 7 layers in the OSI. What are the layers? The first one is the physical layer. Sorry. The first one is the physical layer. Can you see this? Physical layer. Then is data link layer. Then is network layer. Then is transport layer. Then is session layer. Then is presentation layer. Application layer is the last. Can you see that? From the bottom to top. These are the 7 layers. Right? What is the work of the physical layer is it will take convert your data into binary format, right? In bits, and then the data link layer will check for any errors or check for any problems which have occurred during data transmission. If there is any problem, so it will check for the errors. And in the network layer, they will divide the data into packets, right? And and attach the frame and for the source and destination address with the packets, right? And see which is the best path to transfer this data to the destination. And in the transport layer, the TCP/IP will transport it to the destination through the protocol TCP, that is Transmission Control Protocol. And in the session layer, sometimes you see when you do internet banking or something like that, so there is a connection made between you and the server, So for a time being, the session is created, right? If you don't do anything, it automatically logs you out from the system, right or wrong?
Yes.
Right? So that session layer does that. So for if you are connected to the other system, for how much long your connection will be there, that is session layer. And then presentation layer is that in what format the data will be transferred to HTTP, or which kind of thing, or which application you will be viewing that data, whatever. And in the application layer, the data is actually transformed in the form which was actual form of your data, right? Whether it is whatever extension and whatever file it was, so it is the actual data which is with you. So that is what the OSI model does basically. So that was the first model which was created for transferring data, the 7 layers. Now DARPA layers have been created, which is also known as internet layers. What they have done is they have made from 7 to 4 layers they have done. What they have done is the physical and the data link layer is a one layer, network interface layer. Network layer has become internet layer. Transport layer has become, that is transport layer only. And application, presentation and session layer has become application. So they have made it an internet layer or a 4 layer standard. You understand? Right? So that this is what right now they are following. 4 layer format, internet layer, DARPA layer, right? This was the first model which was created for transferring. And what all protocols are working in the layers they have given you, like in the physical and data link, that is network interface layer for the DARPA, you have Ethernet working 802.11, wireless LAN, frame relay, ATM. These are the standards which are working in this. Then in the network layer, or you can say internet layer, there is IGMP, ICMP protocols, IPU version 4 and IPU version 6. There are different kinds of protocols. In transport layer, you have TCP and UDP, transmission control protocol and user datagram protocol. And in the application presentation session layer, that is your application layer, it is HTTP, hypertext transfer protocol, FTP, file transfer protocol, simple mail transfer protocol. DNS is domain name system, RIP, SNMP. These are the different protocols which are working in each layer. Right. So we talked that each suite will have some kind of protocol which is working in each layer. Right. So these are the different protocols, but generally you will not get the protocols. You will only get what is the protocol, the definition. You will not get which protocol is working in which layer. Right. Just for information, we have seen that. Right. Then for wireless LAN, you have 802.11 standard IEEE and shares many properties with wired Ethernet, and there are synchronous optical networking also. You don't need to know that. That is asynchronous transfer mode is also there. You should. That is not your concern. So, what are the different types of network now? Now, can you see the different types of network? See, it keeps 9 kinds of network here they have given. One is personal area network. Do you know what is personal area network?
It is just restricted to one entity or one.
Yeah. Suppose I am there and in my room a mobile is there, a laptop is there, whatever devices I have in my home, in a room. So those are personal area network.
So
I'm
can you call a
connected.
mobile data PAN network?
Yes, I'm just saying all the devices are connected to your network to your modem or whatever.
Yes,
Right?
but I'm saying about mobile data, like from the SIM card.
That is different. That is
Oh,
different. We are just saying that personal area network will be all the devices which are in a single room and you are connected them
okay.
to communicate. Right? So that is a personal area network. Right? And local area network, when you connect computers in a building, in 1 kilometer area. Right? Campus area network, like colleges. Just university connects its departments or colleges, that will be campus area network, right? And
Yes.
metropolitan area network will be connecting metro cities or cities, right? Wide area network will be the whole world is connected, all the computers are connected with each other, right? Then there is also storage area network, SAN. There is virtual private network, VPN. You must have heard about. The companies are using this network for so that their employees can work from their home and connect to the VPN network and connect to the server of the company server. Right. So work from home. Many companies have put this VPN network, and there are client server network, and there is peer-to-peer network. So one by one, we'll see all these networks. So this is a personal area network. Can you see that? Personal area network is a computer network used for data transmission among devices such as computers, telephone, tablets, and personal digital assistants. Right? So you can transfer data from computer to tablets to personal digital assistants or your mobiles and all that. That is a personal area network. That is basically in my home. My devices I am connected. Right? Also known as HAN home area network. Right? Nowadays, so you also are what you are doing is you are getting devices also where your mobile can operate the devices, right?
Yes.
That kind of a system is also there. So all those things are personal area network. So PAN can be used for communication among the personal devices themselves, interpersonal communication, or for connecting to a higher level network and the internet and uplink, where one master device takes up the role as internet router. So this is a personal area network. Right. Then you,
can router be the example of personal PAN?
no, router cannot be the example of personal PAN. That will be like if you are having like a master device will be there, like your mobile. Mobile will be the master device. Through that you will have a Bluetooth or internet based connection to the devices in your house, and you can operate that through the mobile. That kind of a thing. Can you understand?
Yes, ma'am.
That will be PAN.
Sometimes, ma'am, when we connect to a certain network, it shows a pop-up. Do you want to set this as a default home network, public network,
Yeah.
or I think it's home network, I guess. So are
Hmm.
this something related to this topic?
No, that is generally done when you connect your PC to a network. Suppose in your office or in your home, if you have another kind of a network in your home, and you try to connect a device to that kind of a network, so it asks you whether it is a default network should be this, or it should be a home PC or whatever. Public or something like that. If you attach a new device, so that kind of a thing will be there. Otherwise, so it is generally a PAN area network, means all the devices which are in your home and you are communicating with the devices through
They
a
will all
master device. So that is a PAN.
yes.
When we talked about local area network, so local area network is within a building or 1 kilometer area. Right, so Xerox Corporation worked in collaboration with DEC and Intel to create Ethernet, which is the most pervasive LAN architecture used today. Right, and Ethernet has evolved and has seen significant improvements in regard to speed and efficiency. So basically, your cable, your wire-based medium, generally you are using, right? Your switch is being used to connect from one level to the other level, right? So that is there, or you can use a bridge also. An upside of a LAN is fast data transfer with data speed that can reach up to 10 gigabits per second. So basically it's a fast data transfer network, local area, because it's in a limited area. Can you understand? It's in a limited area. So it's a fast data transfer, because if it is in a building or something, so there is no problem in transferring the data. It will be faster. Right, so that is local area network. Other significant LAN technologies are fiber distributed data interface, FDDI and token ring are also there, but we are not talking about that. Right. Then you have campus area network, and this is larger than the LANs, not within one building, it will be more than one building, right? Like in a campus or in colleges, buildings are attached with each other, right? So larger than LANs but smaller than metropolitan area networks. These types of networks are typically seen in universities, large K-12 schools, districts or small businesses. Right? Can you understand this? Campus area network.
Yes.
Right. Then they can be spread across several buildings that are fairly close to each other so users can share resources. So that is your campus area network. Then you have metropolitan area network. Metropolitan area network will be connecting cities. Right. So a MAN is larger than LAN but smaller than or equal in size to a WAN. Wide area network, it can be equal to a size of a wide area network or small. It can be smaller than size to a wide area network, but it is larger than local area network. The size range anywhere from 5 to 50 kilometer in diameter. Right. So this much cities or this much area you can cover. MANs are typically owned and managed by a single entity, generally by a single entity. That means suppose a company whose headquarters are in Delhi or Bombay or something like that. So they want to connect their servers with each other or computers with each other. So they will set up a metropolitan area network. So this could be an ISP or telecommunication company that sells its services to end users in that metropolitan area. Can you understand that? So ISP, suppose Airtel in Delhi or Airtel in Bombay or Airtel wherever I'm just saying, an ISP internet service provider is Airtel. So what in a metropolitan area network, ISP will sell its services to the end users, right? So it will have a base station at Delhi, and all the computers in the area will be covered by Airtel. That this is there, this is there, this is to give internet to the customers. Can you understand that? Metropolitan area network, right?
Yes.
So that is there for all intents and purposes. Man has a sorry. So for all intents and purposes, a man has the same characteristics as a van with distance constraints. So there is a little distance constraints because all the computers in the whole world are not connected, but still it can work as a van also. So that is there. Then when we talk about wide area network, so wide area network is what? Is your internet. Yes? Over a large area. All the computers, if you connect in the world, then what it will become? If all the computers are connected in the world, they will be connected through internet only, na? Right? So that is wide area network, and it exists over a large area. Data travels through telephone or cable lines, usually require a modem. The world's largest wide area network is the internet, right? What is the definition of internet? Anybody knows the definition of internet? Internet means interconnection of networks. Internet, right?
Yes.
Right. Then we talked about storage area network. So SAN may be referred to as a sub network or special purpose network. It's a special purpose network, right? And its special purpose is to allow users on a larger network to connect various data storage devices with clusters of data servers. So just like a cloud, what does a cloud do? It is providing you storage for your data, na?
Yes.
Yes, so
Yes, ma'am.
it's SAN network is just like that kind of a network, a cloud computing network, where certain computers on the network want to either a mail server. Mail server is also inside a SAN. Your mails are stored where? On your PC or on the mail server?
Mail server, not on PC.
Right, on the mail server.
Mail
So it is
server,
just
ma'am.
like a storage area network. Then you also have application servers also, right? Database servers also. So all these servers, when or whatever devices or resources you want to use, that are also there on the SAN network. So you can use those data storage devices and the different peripheral devices also. So SAN can be accessed in the same fashion as a drive attached to a server. Right. So again, you will have a username password created for this type of a thing, and you will be connected with the internet to the SAN network, and you can store whatever data you want. Right. That is storage area network. It's a special kind of a network. Among PAN, LAN, WAN, and WAN, it is a separate kind of a network, not that kind of a network. Right. Then you have VPN, virtual private network. VPN is a private network that can access public networks remotely. Can you understand that? Public networks remotely. So
Yes.
VPN uses encryption and security protocols to retain privacy while it accesses outside resources. So basically, suppose some person is outside his company. What the VPN network will do is it will allow access of public networks remotely, but and it will also have security protocols attached so that unauthorized access and all that will not be there, but you are able to access the resources from outside. Right? So suppose I'm sitting at my home and I want to connect to my office and see what data and all that in my database server or whatever. So I can connect to the VPN network of my office, and I can connect to the database server. Right? That is VPN, virtual private network. So when employed on a network, VPN enables an end user to create a virtual tunnel to a remote location. Typically, commuters use VPN to log into their company networks from home. Right? So it creates a virtual tunnel, a kind of a security tunnel where you are connected with your company server from your home, right? And and it uses some encryption. Encryption. Do you know what is cryptography? What is encryption, decryption? Anybody? No?
No, ma'am.
Encryption, I guess, changing a data into a particular format.
Yeah. So suppose some secret information is there. So earlier, what they used to do is they used to write in some other format, right?
Yes.
So same way in computers, your data is converted to some other format so that the other person, even if he gets the data, he will not be able to decrypt it. That means not make the data in the original format. So that is known as encryption. And this encryption and decryption comes in cryptography. Your data is encrypted or decrypted. That is the technology known as cryptography. Right? So can you understand what is a VPN network?
Yes.
Yes, ma'am.
Right. So from remote location, you can access your company server. So that is VPN, and authentication is provided to validate the identities of two peers. Two peers means two persons. So authentication means what? You have to authenticate that you are the valid person who are accessing this network. So you have to give your username password created by the company, right?
Yes, ma'am.
So, and also confidentiality provides encryption of the data to keep it private from prying eyes. That means there will be encryption of data so that confidentiality is maintained. No other person will be able to see the data or access the data, right?
Yes, ma'am.
So, and integrity is also maintained. That is to ensure that the data sent between the two devices or sites has not been tampered with. There is no way they should maintain the integrity that the data which is transferred by the person to the server or from the server to the person is not tampered, right? So that is integrity. So that is your virtual private network. Then is client server network. This we have already talked about also. The client server network arrangement is just like service. There is a dedicated computer called server, right? And the server responds to the request of client. And the server is a central computer that is continuously available to respond to requests from clients for file, print, application, and other services, right? Just like in central server, just like a server which is located at a central place and number of clients are connected to that central server, and whatever requests they are doing to the server, server is responding to those requests, right? Most network operating systems adopt the form of a client-server relationship. So if you are talking about a network operating system, most of them follow this approach only, client-server network.
Yes.
Right. And typically desktop computers function as clients and one or more computers with additional processing power, memory and specialized software functions as servers. Right. So those computers which have like mainframe, which have more processing power and memory and this specialized functions, so they will be your servers, and normal desktop computers will be your clients. Right. So that is your client server. And what is peer-to-peer network? Usually very small network. Each workstation has equivalent capabilities and responsibilities, does not require a switch or a hub. These types of networks do not perform well under heavy data loads. Can you understand this? There is no switch or hub. We have just connected 2 or 3 PCs together or 10 PCs together. Do you understand?
Yes.
A small network, and there is no switch or hub to transfer data from one computer to the other. There will be wire or connectivity between the PCs, and if there is heavy, if suppose 2 or 3 PCs are simultaneously receive the data, so there will be heavy data loads there, and the data will not reach the destination on within seconds or something like that. That is a problem in these types of networks, right? So that is your peer-to-peer. So these were your different types of networks which we talked about. Then the other thing is network topology. Hanji. Network topology.
Sorry.
माइक है साइलेंट कर लो.
હવે मैं वो नहीं करूं. ठीक છે. मारे धुन में समाती मांग कर रहा हूं. मारा से पूछे हमारे तो
Whose mic is it? Please mute it. Hanji. अच्छा. Do you know what is the topology?
Is it about topography or something?
No. Arrangement of computers. How do you arrange computers? How do you design that? How it will be the arrangement of computers is known as topology. Do you understand?
Okay.
अरेंजमेंट कैसा होगा, किस तरह से आप कंप्यूटर्स को रखोगे, दैट इज नोन एज नेटवर्क टोपोलॉजी. So network topologies defines the structure of the network. What will be the structure? Right. So physical topologies are there. It defines the actual layout of wire or media. How you will keep the wire and where the computer will be is known as a network topology, the structure of the network. So there is bus topology, ring topology, star topology, tree topology, and mesh topology. Right? So what, and there are logical topology also. It defines how the host access the media to send data, like you broadcast, or token passing. Do you know what is broadcasting?
What you are doing right now, you are broadcasting your screen to us.
Yeah. So all the people can see, like in a television. Television is doing what? That television is just kind of a broadcast, right? So
Sending
logical.
sending
Yeah, all the people can see.
all information to sending one information to all participants.
Yeah,
That is broadcast.
that is broadcasting. So that way. And token passing is, suppose the person who is intended to send the data, he will take the token and send the data and return the token back when he has sent the data. That kind of logical topology is also there. So that we'll talk about, but first we talk about the physical topologies. how the arrangement of computer is done, right? There is hybrid topology also, but we will talk about that later. So what is a bus topology? Bus topology is just like there are terminators at the end of the bus, and in like a bus or like a straight line, right? A wire is there, and on the wire computers are connected. These circles which you see are the computers. These are the computers, nodes which are connected. Can you see that? Right, all the devices are connected to a central cable. This is a central cable, this is a straight line, this is a central cable, right, called bus or backbone. So a single cable is there, and on the single cable all the computers are connected, and at the endpoints are the terminators. Right, there are terminators at each end of the bus that stops the signal and keeps it from traveling backwards. So the signal can travel from one wave to the other, not travel backwards. You understand? So these are terminators to do that, endpoints, right? What is the problem with this network? Advantages is there is no central controller, there is no controller here, and control resides in each station. Whoever wants to send the data, he can send it. The less interconnecting wire is required because single wire is there, so that you will not require more wires, so it will be less interconnecting wire will be there. Ease of installation is there, easy to install it is, and backbone cable can be laid along the most efficient path and then connected to the nodes by drop lines of various lengths. Right. So backbone cable can be laid and it is easy to install this kind of a network. Right. But what are the disadvantages? It is possible that more than one station may attempt transmission simultaneously, collision of contention, it is known as. That means simultaneously if to one or more station attempt to transmit the data, so there will be collision of data in that. Right. Then difficult reconfiguration of fault isolation. Suppose one computer breaks down here. In this bus topology, one computer doesn't work or breaks down. So suppose this computer wants to send data to this computer, he won't be able to send because a breakdown in between of this computer is there. So your network is not working now. Do you understand? Right? Because this is a single wire. Right. Then a fault or break in the bus cable stops all transmission even between devices on the same side of the problem. So even one computer, if it breaks down or cable stops working or cable has some problem, all the computer will not be able to transfer the data. Right? This is a problem, disadvantage of a bus topology. Can you understand this?
Yes, ma'am.
Right. Then the other one is the ring topology. Now, in a ring topology, the first computer will be connected to the last computer, just like in a circle, right? A ring will be created. Can you understand that?
Yes.
Right? So in a circle, computers are connected in a closed loop, right? And each device is connected directly to two other devices on either side. So suppose if this device is there, so it is connected with this and this device on the other, on the left and right side, right? With two other devices, right? And advantage of this kind of a network is avoids the collision that are possible in the bus topology. Right, if simultaneously two of the computers are sending data, so the person can send from this side or this side. The collision will be least from the bus topology. Each pair of stations has a point-to-point connection. So each pair of station have point-to-point connection, means there are two connections point-to-point where it is connected, right? And a signal is passed along the ring in one direction from device to another until it reaches the destination. So whoever wants to send the data, so for in one direction the data will go from one computer to the other, and the computer where it wants to reach the destination, it will until it reaches the destination, it will move on from one computer to another and reach the destination on computer. Each device incorporates a repeater, right? So if signal strength becomes low, so there is a repeater which makes the signal strength more relatively easy to install and configure, right? And fault isolation is simplified. You can find out if there is a fault in a connection, that is also simplified. But what is the disadvantage is a break in the ring. Suppose just a station is disabled, or what will happen? Suppose this computer is not working. So will your ring has not be broken or not?
Yes.
Yes, sir.
Right. So this is a disadvantage, that this ring will not work. What happens in a ring topology is, suppose this computer wants to, how does it make collision, does not collide with the other persons? What happens is there is a token passing mechanism followed. So suppose this computer wants to send data, so it acquires the token, and the token is acquired by this computer, so other computer know that the token has been taken by this computer, so they will have to wait for data transmission. And when this computer transfers the data to the destination wherever he has to make, and once the data has been transferred, it will release the token, and then other computers will try to acquire the token, and whichever computer acquires the tokens, he will transfer the data, others have to wait. So this is how it simplifies the collision problem. Do you understand? So that is what happens in the ring. But only problem is if one of the computer breaks, then the whole ring is not working, right? And unidirectional traffic is there. Only in one direction, clockwise it can transfer. Only in one direction it can transfer. Vice versa, it cannot transfer. Can you understand? That is also a disadvantage, right?
Yes.
Right. Then is star topology. Now in a star topology, all devices are connected to a central hub. You have seen the hub,
Yes.
right? So the hub has number of connections. So all the computers are connected to the hub, right? And nodes communicate across the network by passing data through the hub or switch. So this device, central hub, can be a hub or a switch. So whatever devices are connected to the hub or a switch, so first the computer wants to send the data, so it comes to the hub or the switch, and the switch decides, sees which computer it is intended, and that computer receives that data. So it has to pass through the hub or the switch. Right. So what is the advantage is that it is easy to install and reconfigure, right? And what was the other disadvantage of ring and bus was, if I want to add another computer, can I add in a bus? Later on, I have created this bus, and now one more computer needs to be added. Would I be able to add in this? It will not be possible,
No.
because I have already terminated and the wire is complete, right?
Yes.
So, and in a ring also, I have created the ring, and would it be possible to have another computer in the ring?
No. You'll have to break it.
Extension of these networks will be a problem. But in a star network, if your switch has a number of connections, you can attach as many computers as you want, and you can also connect another switch also and have more computer attached. You understand?
Yes.
So that is the facility of a star. So robustness, if one link fails, suppose this link fails here, then also the network will not breaks down. The network keep on working. This computer can transfer to this can transfer to this, because it has to go from the hub or the switch. So even if one computer doesn't work, does not matter, right? Or link is not working, it remains active. Do you understand? Easy fault identification is also there. So it is easy to find out which computer is not working, and has to be, or the link is not working. So that link light will not be blinking in the switch. So it is easy to find out that which computer is not working, or which link is not working. Do you understand?
Yes.
And what is the disadvantages are, the devices are not linked to each other directly. They are not linked to each other directly, no?
They are
It
linked
has
with
to
central hub.
go from the central hub. Right. If one device wants to send data to another, it sends it to the controller, which then relays the data to the other connected device. Right. So from the central point, it has to go. Right. So that is a disadvantage. Maybe a security disadvantage will be there because you don't have a direct connection to the other device. Right.
Yes.
So otherwise, it is a good, generally in small organizations, the star network is generally used. Right. From the ring and the bus, one more disadvantage of star is that it requires more wire than both the other ring and bus topology. Can you see that? To the central hub, from this one computer will have wire, this computer will connect with the wire, this computer will connect with the wire, this computer. Do you understand?
Yes.
It will not require one wire, it requires more wires. As many computers you connect, as many wires you will require to connect. Right, so it will become a little expensive for the wire part of the thing.
But it can be altered with wireless as well, right? Because
It can be altered with wireless. If you have wireless devices, it can be altered with wireless.
can we also add that as an advantage that if anything happens to the central hub, there's no use of
Then
attaching n
if
number of
something happens to the central hub, then all the devices will not be able to communicate.
Yes, we can add as that was a third disadvantage.
Then tree or hierarchical topology is just like a tree like of structure where it allows more devices to be connected to a single central hub and can therefore increase the distance a signal can travel between devices. Right. So there will be a backbone cable, like in a bus there was a backbone cable, right? And on that cable, number of networks are connected. Do you understand?
Yes.
So there are number of hubs and hubs here. This hub is there, this hub is there, this hub is there, and on that hub, number of computers are connected to the central backbone. So that kind of a thing is known as a branch, just like branches of a tree. It is connected. So it allows the network to isolate and prioritize communication from different computers. And the disadvantages are the devices are not linked to each other directly. Right? If one device wants to send data to another, it sends to the controller, which then relays the data to other connected devices, just like in Star. Right? And if this backbone doesn't work, then what happens?
Again, nothing will be of any use.
Right. So that will be no help. These computers can communicate with each other, but these computer cannot communicate with these.
Yes.
Right. So that will happen. Right. And the addition of secondary hubs brings two further advantages. Right. That will be disadvantage. If you want to increase you add the secondary hubs, more hubs. So that will create a problem for transferring one form of data to the other. That will be a problem. That is not an advantage. That will be a problem for that. Right. Then you have mesh. Now, if you see this network, can you see all the computers have a dedicated line to other computer?
Yes, they are all interconnected.
All are interconnected. That means if suppose this line breaks down, right, from this computer to this computer. So that doesn't mean this computer cannot send data to this computer. It can still send from another computer also, right? So basically what this is, each host has its connection to all other hosts. Mesh topology is implemented to provide as much protection as possible from interruption or service. And a nuclear power plant might use a mesh topology in the network control system. The nuclear power plant can use that. And although the internet has multiple paths to any one location, it does not adopt the full mesh topology. So basically, mesh topology is implemented to provide as much protection as possible from interruption of service. So basically, why mesh is taken care of is that even if I have a dedicated connection, so I will be transferring it faster to the other computer. But what will be the disadvantage of this? You will require a lot of wires to connect one computer to the other, and all the computers need to be connected with each and if you have more computers, how many wires will be there? Right? So the use of dedicated links guarantees that each connection can carry its data load, thus eliminating the traffic problems that can occur when links must be shared by multiple devices. And it is robust. If one link becomes unusable, it does not incapacitate, affects the entire system. And privacy and security, every message sent travels along a dedicated line, only the intended recipient sees it. And point-to-point links make fault identification and fault isolation easy. So these are the advantages. And what will be the disadvantage? A large amount of cabling is required. A large amount of input-output ports are required. Installation and reconfiguration are difficult. And the sheer bulk of the wiring can be greater than the available space in the walls, ceiling, for floors and can accommodate. And the hardware required to connect each link, input-output ports and cables can be prohibitively expensive. Can you see that? What are the advantages and disadvantages?
Yes.
Right. So dedication is okay that your data is not intended for the privacy and security is maintained because you have a dedicated line, so that person will only receive it, and there will not be any traffic only because through dedicated line you are sending the data. But the problem is that so much of cabling, input output ports, installation will be required, and so much of space also will be required to put the wires, and all that is also not there. So it will be too much expensive to make a mesh topology, right? Can you understand this? The types of topologies?
Yes, sir.
Ring, star, mesh, tree, right? These are the topologies, the structure, how arrangement of computers is done. Then what is a wireless network?
Which has no guidelines, you can say, or not a guided type.
Yeah. So we talked about the guided medium and unguided medium, right?
Yes.
So here there was wireless media also, right?
Yes.
So we will be talking about now wireless networks. Just to go to that part of just. So we have to talk when we are talking about wireless networks. So wireless network is a type of computer network that uses wireless data connections for connecting network compute nodes. Like, for example, Bluetooth and Wi-Fi. Yes, you are connecting right now. Generally connect through Wi-Fi or Bluetooth nowadays. Yes.
Yes.
So what is Bluetooth? Bluetooth is a short-range wireless technology, standard used for exchanging data between fixed and mobile devices over short distance. So for a short distance, if you want to exchange data, then it is a fixed and short distance mobile device technology. Basically, it is using UHF radio waves in the ISM band from 2.402 gigahertz to 2.48 gigahertz. So there are frequency bands of radio waves. We are not talking about that. So on that, UHF is one of the bands on which it is transferring the data, and the band's signal strength is 2.40 gigahertz to 2.48 gigahertz frequency. Right. The IEEE standard Bluetooth as IEEE 802.15.1, but no longer maintains the standard. So there is no right now this standard is not maintained, but they have made this standard or protocol standard for the Bluetooth. Right. Do you know how many devices you can connect to the Bluetooth at one time?
I guess it's just one.
2.
It is 8.
8.
8 devices can be connected. right? Then Wi-Fi. Wi-Fi stands for wireless fidelity. The full form is wireless fidelity, and Wi-Fi is a local area wireless technology. Wi-Fi networks use radio technologies to transmit and receive data at high speed. It is based on IEEE 802.11 family of standards. An access point. The access point is a wireless LAN transceiver or base station that can connect one or more many wireless devices simultaneously to the internet. That can be your router or a broadband modem, right? So that this is Wi-Fi, right? You know the symbols of Bluetooth and Wi-Fi, right?
Yes.
Then what is internet? We talked about internet is interconnection of computers,
Networks.
right? How information travel to the internet. So your data is divided into packets, and the packet will have a header which provides a complete destination address for the packet. So here your address will be there, where destination the packet has to reach, and then a data block. This is the portion where the data part which it is carrying, the bits, right? And I told you that the whole data cannot transfer in your wire because it has a limitation. Bandwidth is limited, speed is megabits per second rate is there. So if it is 16 GB, 20 GB of data, or 16 MB or 20 MB of data, so it has to be divided into packets per megabits per second, right? And then how much is your bandwidth of your wire, and that much data block one packet will be having, so in bits, right? And this is the sequence ID or ID where the information belongs in relation to the rest of the information. That means your which packet number it is, sequence ID. That packet number 1 is this, packet number 2 is this, that kind of a sequence ID. And this is the end of message, that is ID is the end of the packet. That means this is the end of the packet can have any other ID, that this is ending packet. So this much data, this is how the data travels in packets. Do you understand? Any doubt in this? So what is the simplest definition of the internet? It is a network of computer networks, right? Network of networks, interconnection of networks, right? A page on the network, whether it's full of words, images, or both, doesn't come to you in one shipment. Do you understand? Suppose you are accessing a website, so a page you want to open which has images, text, and all that. So that also doesn't come to you in one go, right? It's translated into digital information, chopped into 1500 byte pieces called packets, and sent to you like a puzzle that needs to be reassembled. Each part of the packet has a specific function. Do you understand? What does it mean?
Yes.
Right? So a page can be, suppose 1 MB, 2 MB, 3 MB, whatever it may be. So the page may be having images, text, and all that. So the whole page will not come to you. What you think is, when you open it, you don't seem to know that it is coming in packets. Actually, it is divided into packets, and each packet will have a destination address and the sequence ID and all that. And that bits are transferred to the destination, and they will not reach in the same order. They will reach it as a puzzle. So 10 will reach first, second, 2 will reach last, something like that. And then it is rearranged at the destination, and the page is displayed on your browser. You understand?
Yes, ma'am. And which portion or who basically does the job of reassembling these packets?
That is done by your modem or your router.
Okay.
Right, and it again transforms the data, and it converts the data into analog and digital format. Right?
Right, got it.
Right, how information travels through the internet? When you connect to a wide site through an ISP and start exchanging information, there isn't a fixed connection between your computer and the web server computer hosting the website. Instead, information is exchanged using the best possible path at that particular time. Special computers called routers determine these paths at avoiding slow links and favoring fast ones. So I have told you, na, what does the router do? They will find out the best path through which your data should move to the destination. Do you understand?
Yes, sir.
This is generally what is happening in the internet. Then we have already talked about the cloud computer. Do we need to discuss it again? The internet-based computing whereby shared resources, software information are provided to computers and other devices on demand like electricity grid, right? So I'm not talking about the cloud right now. So properties and characteristics, they are given: internet as a service, platform as a service you can give, software as a service you can give. So we are not talking about the cloud, there are different kinds of cloud. So can you understand this topic, networks, up to
Yes.
here,
Yes, ma'am.
right? But there is more also in your block. There will be more. We have talked about many things. You have to go to block 3, unit 1, and you will see there are certain things in the book also given. You can read them also. Apart from what I have told you, I'm just has everybody put their attendance?
Yes, ma'am.
How to do it? मैम कैसे करें?
हाँ जी, मैं बंद नहीं कर रही हूँ अभी, मैं दिखा ही रही हूँ. बोलो, बोलिए क्या हुआ?
मैम अटेंडेंस कैसे करें? मेरा
बताया तो चैट बॉक्स में अपना नाम और एनरोलमेंट नंबर लिख दो.
ओके मैम.
हाँ, रोज ही बोल रही हूँ मैं ये. अच्छा, यहाँ अगर आप नेटवर्किंग है आपका जो ब्लॉक 3 यूनिट 1 है, आप देखोगे व्हाट इज द कंप्यूटर है, एडवांटेजेस क्या है कंप्यूटर, मतलब कंप्यूटर नेटवर्क, इंटरनेट, डेटा कम्युनिकेशन सिस्टम, डेटा ट्रांसमिशन चैनल हमने देखा, गाइडेड अनगाइडेड मीडिया है यहाँ पे देखा, नेटवर्क टोपोलॉजीज है, बस टोपोलॉजी, रिंग, स्टार, और नेटवर्क क्या क्लासिफिकेशन है, लैन, लोकल एरिया नेटवर्क, मेट्रोपॉलिटन एरिया नेटवर्क, वाइड एरिया नेटवर्क. फिर यहाँ पे रेफरेंस मॉडल दैट इज ओएसआई मॉडल के बारे में बताया. नेटवर्किंग डिवाइसेस हमने डिस्कस की, नेटवर्क इंटरफेस कार्ड, मॉडेम, रिपीटर, ब्रिज, हब, स्विच, राउटर, गेटवे. अब मॉडेम होता है, मॉडेम क्या होता है? मॉड्यूलेटर, डीमॉड्यूलेटर, जो कि एनालॉग सिग्नल को डिजिटल और डिजिटल सिग्नल को एनालॉग में कन्वर्ट करता है. डू यू अंडरस्टैंड? पता है मॉडेम के बारे में ना? आप जब इंटरनेट से कनेक्ट करते हो तो जो वायर होती है, वो जो टेलीफोन वायर होती है, वो एनालॉग सिग्नल ट्रांसफर कर सकती है. यू अंडरस्टैंड? एंड आपका कंप्यूटर डिजिटल है, बिट्स में अंडरस्टैंड करता है. तो मॉडेम क्या करेगा? एनालॉग सिग्नल को बिट्स में कन्वर्ट करेगा, डिजिटल में. और डिजिटल फिर अगर आपको भेजना है कुछ टेलीफोन वायर से किसी को, तो वो डिजिटल को एनालॉग में कन्वर्ट करेगा. दैट इज अ मॉडेम. फिर हमें अब ये पढ़ना है, ये रह गया है हमारा इंटरनेट एंड इट्स सॉफ्टवेयर कंपोनेंट्स. आईपी एड्रेस क्या होता है, व्हाट आर द आईपी एड्रेस एंड डीएनएस एंड ईमेल. यू अंडरस्टैंड? दिस इज व्हाट इज लेफ्ट विच वी ऑन. सो व्हाट आई एम टेलिंग यू, जरूरी नहीं है कि आप मेरा वाला देखो, जस्ट रीड दिस कंटेंट आल्सो ऑफ योर्स. ये जो आपकी बुक में दिया हुआ है, रीड दिस, एंड इफ यू आर नॉट एबल टू अंडरस्टैंड, we will go through whatever you are not able to understand, we can go through again, right? इसमें सब कुछ दिया हुआ है आपको.
Yes, ma'am.
Devices वगैरह के बारे में. Then tomorrow we will discuss about the IP addresses and the domain DNS, right?
Yes.
Right.
Okay, ma'am.
Anything else?
No.
No, ma'am.
Ma'am, what kind of questions can we expect from all these topics and all these things? Like, do we have to
You
memorize
can
all
have
the?
any question. You can have a topology question also. What are the different types of network topologies? What are the different types of networks you have? What is a router? What is a bridge? What is that kind of a question can also be asked. What is OSI? Right? What are the layers in the OSI? Any kind of question can come. Right? Just hold on for a second. Anything else you want to ask?
Only I have one question related to assignment. If the LMS is showing 13th April is the last day to submit,